Victor, with systems like the upcoming Stratolaunch plane and small rockets like Rocket Lab used to launch microsatellites, it feels like we have more methods than ever to launch things into space. Do you envision any additional methods like electromagnetic railguns or space elevators? They're both great ideas. The electromagnetic railgun is a fantastic idea for a vacuum world. Not nearly as effective on Earth. I mean, on the moon, for example, you don't need a ramp, you don't need anything. You know, you just lay a straight rail for some distance, 10 kilometers or something like that, and you accelerate it and up it goes. But this is an important thing that most people don't understand, and that is how orbits actually work. Most people would assume that if you shot something off the planet with a railgun, once it left the rail, it would go into orbit. But my understanding of this, might be mistaken, I don't think I am. My understanding of this is not the case at all. Depending on how fast you shoot it would determine how high its apogee is, but it would eventually come back down and land and crash. Because in order to orbit, you not only have to get the thing going fast enough, but once you've reached your optimum orbit, then you have to circularize the orbit. You have to do a secondary burn, which brings the bottom of the orbit up off of the surface of the planet and makes it elliptical or circular, whatever shape you want. So a railgun gets you off of the surface, and the amount of energy needed to circularize an orbit is far, 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 far smaller than it is to get it off the ground in the first place, but you still need something. So, limitation on that, but still, if you really want to move tons of stuff out there, you just throw it some good long distance or give it damn near escape velocity, catch it with something. Speaking of out-of-the-box solutions, and Burt Rutan earlier, hadn't read this question, but it's a nice segue. Just to show you what kind of a genius, Burt is, he's done a presentation on this. He kind of swore me to secrecy about it when he first told me about it. But he's done a presentation on it, and basically, there is... Stratolaunch is the biggest airplane ever made. I had a chance to spend a couple days with the guy who designed that wing. He's a test pilot for them. He's a terrific guy. Very young guy, terrific guy. It's got 6 747 engines. They scavenged 2 747s to give them 6 of the 8 engines, 2 engines in reserves and spares. But it has the largest wingspan and is considerably the largest airplane ever to fly. And like so many of Burt's designs, Burt didn't do the technical design on Stratolaunch. I suspect he had a lot to do with the concept of it, because it sure as hell looks like a Rutan airplane. But basically, it's 2 fuselages, wings extending on either side, wing connecting the 2, and from where the 2 wings connect to the 2 parallel fuselages, down below that is a cradle that holds the actual rocket. And then by going up to some altitude, 40,000 feet, somewhere in that ballpark, and getting a 500-mile-an-hour head start, you would think you would get significant gains, quite significant gains, in terms of getting that thing to orbit. But since the rocket doesn't have a wing on it, you've got a big problem. And that problem is this. If you take a rocket up to 40,000 feet and you're flying more or less level, and you drop that rocket, it's going to fall under the power of gravity. And if you start to light the motor and deflect the thrust as much as you can to get that rocket to start to climb, it will eventually climb that angle, I believe is called the alpha. So it will eventually climb back up to vertical, but by the time it's turned the corner from falling horizontally to going back up, you've lost almost all of what you've gained by being that high and that fast in the first place. Now, if you have a wing on it, that's a different story. If you have a wing, the wing takes the aerodynamic load, turns that corner much, much faster at a much lower cost energy, and that's why the Pegasus satellite has a little tiny wing on it, I think. But Burt's idea was just, as usual, way beyond that. So what Burt was talking about doing was having a craft that looked a bit like Stratolaunch. And he was going to tow it on a cable behind a big airplane, like a maybe 767 or an L-1011, something like that. He was going to tow it off the ground, and once it got into the air, they'd lay out a lot of cable, have a very long, high aspect ratio wing, really good lift, and they would get this thing up to 40, 50,000 feet, and then the magic would begin because, as I recall, Bert had the thing on the back of the plane, not underneath it. So then what he would do is something that was just, I heard him say this, and it's like, for God's sakes, Rutan, are you ever gonna give up? Amazing, all of us who know a tiny little bit about these things. So Bert's he said, if I have this thing in tow and I've got like a carbon nanofiber cable, something really, really, really strong, he says, then what I can do is this. He says, I can have the glider pitch up. I don't know how many of you have ever seen a glider being launched. They do this in Europe all the time. Here in America, we launch our gliders almost exclusively from other airplanes. My first 80 hours in an airplane were in unpowered airplanes and gliders behind tow planes. We get tow up to altitude. We'd let go of the rope, and we'd glide on, and the tow plane go back home and land. But in Europe, they do cable launches, which is a winch launch, which basically means you start on the ground, and some enormous distance out there is a winch, and you say go, and this thing starts reeling in the cable real fast, and as it pulls the cable in, you're going straight towards the winch along the ground. But when you get to flying speed, you put the nose up, and then it goes like a kite. It just basically just arcs up. The tension on the cable is kind of used as almost like a lever to push the glider up over to the top, so at the point that the glider actually starts to do a damn near vertical climb, and as it gets closer and closer to the winch, it essentially becomes level almost over the winch. At that point, you drop the cable and off you go. So Bert said you could do that with this glider that's carrying a big honkin' rocket on its back. You basically get the thing up to a reasonable speed, you start this pitch-up maneuver, and then the thing, and this is where the genius of Bert comes in, he said basically what's happening is when that airplane starts to take the aerodynamic bite, the cable tension pulls on the big heavy jet, and that jet becomes the anchor, and the energy is transferred down the cable to allow this. I don't mean electrical energy. I mean just the kinetic, the mechanical strength of the cable allows this kind of slingshot maneuver. And I forget the number, but he said it's something like it's a couple million joules or so. It's just this insane amount of energy being used. Just slowing down this you got an L-1011, you got guys in it and probably want ballast in there as well. You're towing the glider along. He starts his pitch-up maneuver, and everybody in the big plane goes forward because it's slowing that big plane down, but that's where the energy is coming from. And so as this thing starts its climb, so here's your your tow planes here and the gliders here, and it starts this climb and it goes up, 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 up. And when it reaches this optimum angle, which I want to say is about 65 degrees, 70 degrees, something like that, you've now got the rocket pointing at the exact angle you want it to be at this altitude. And you're at 40, 50,000 feet, and it's going in the right direction, at the right speed, then at the right angle. You just let it go. Bert was talking about floating it on balloons, like kids' balloons. Just let it go. You just undo the strap, and it just goes, and the glider falls away. The rocket's on the exact right angle and the exact altitude. Nothing has to change. You never drop. It's all going up, and he said you could get like a 50% increase in payload to orbit. That's a mind-blowing idea. Mind-blowing. Those are the kind of breakout ideas that change the equation. A 50% increase in payload is game-changing. When Bert was telling me about this, he said in airplane design, you get a 7% increase, you'd kill your mother for that kind of margin. So that kind of out-of-the-box idea is really cool. And also, this one's a little more funny. He was talking about SpaceX. He's a big fan of SpaceX, by the way. The landings and stuff are just impressive, and what they do to the economics of being able to fly those boosters again, return them and fly them is a game-changing technology. But when Bert told me about this, they still hadn't gotten those water landings done just right. And of course, they messed up the one on the Falcon Heavy launch. But Bert said rather than trying to get this thing down on a, postage stamp, He said the best way to recover these boosters is to and he sketched out something. It was like a boat with a giant net on it, but not a flat net, like a catcher's mitt or first baseman's glove in baseball. And it's basically kind of an arc-shaped thing, and he says you basically wait for this thing to come down, you put yourself underneath there, you get a much, much, much larger area, you kind of capture the thing, and you don't have to worry about it tipping over and all the rest of it. Well, damn, man, that is an interesting idea. So, yeah. And of course, the space elevator is the golden calf for all of this. It's tougher than it looks. Most people think that a space elevator is just a really tall building. It doesn't work out that way. In order for the space elevator to work, you've got to have a gigantic, enormous weight on the other end. So otherwise, the structure just collapses. The only way to keep it intact is to keep it under tension, and the only way to keep it under tension is to have like a small asteroid or something anchored to the top that's going around the Earth much faster than it would if it were in an orbit there. So it's basically the rotation of the Earth and everything just basically keeping this thing it's like swinging a rocker on your head, you know. In fact, it's a perfect example. If you think of a sling like a David sling, you know, you're doing this, and it's like, okay, so now we've got this soft piece of cloth that's absolutely horizontal. How does that work? Well, I'm swinging the sling. The only reason the cloth stays horizontal is because the weight of that rock and the centrifugal force of that rock is putting enough tension on that cloth to make it hang out vertically, horizontally like that. So same kind of principle, basically. People don't really appreciate how close space is. It's 75 kilometers. What's that, 60 miles maybe? Something like that? 50, 60 miles? Let's find out, shall we? Because I don't like dealing with kilometers. Those are for weaklings. Pretty sure the number was 318,000 feet. Round numbers divided by 5,280 equals, 60 miles is the legal definition of space. Once you get above 7, 8, 10 miles, really just a little bit higher than where your typical commercial jets cruise, 90% of the density of the atmosphere is in the bottom 10% of the depth of the atmosphere. So it's not a linear thing. The thickest air is much, much, much closer to the ground, and then it thins out much more quickly. But to get into full-on space, 60 miles, which means that at any given time, I could get in my Camaro, point it upwards, and be in space in an hour, and that's if I did the speed limit. I don't usually do the speed limit. I'd be there in under an hour on the freeway, straight up. I don't know whether that's further than people think or closer. Just because it's something I occasionally think about. I'd be interested in asking a question. If I had a map of the United States that was the size of like a table, you know, just about the size of, you know, that size. It's a regular, you know, National Geographic size map of the United States. And I asked people to show me how high above that map they think that airplanes fly. I think that'd be really fun because as far as I can see, it's inside the paper. In other words, the United States is 2,000 miles across, but you're only ever 7 miles high. It's quite a ratio. In other words, we think we're very high and look down, oh, we're so far above them. When you look at the distance and the height, it's shockingly, shockingly low. And yes, I think space elevators only can work at the equator. Bone Canoe, it's my understanding. That have to be true. Yes, it'd be true for the same reason that you can't have an orbit. You can't orbit at 45 degrees north latitude. You can have an orbit that reaches 45 degrees north latitude, but then it's got to go to 45 degrees south latitude. It's a circle or an ellipse rather, and it's inclined. But you can't just orbit around, 40 degrees north latitude. So these things are fun questions. Hey, look, it's 7:30. I'm sorry to have to cut it this short, but I have a bunch of work I have to do tonight as well. I have some plans to try and get space going there myself. In any event, wow, what is this? Hey, it did record last week. Did it record all of it? That's a wonder. I'll adjust it. That looks like 182. This would be 183. Thanks again for our members. By the way, it's a number of people who joined us 2 years ago when PJTV sailed into the West. A number of these annual memberships are renewing. And to be honest with you, especially with the shadow banning and all the stuff we've been facing, it's extremely good timing. So if you're one of those people who've been with us for, these 2 years, and especially, I know things get spotty and shaky sometimes with me in terms of not being able to do all the content that I want to do, and spend a year with the NRA and time working on this CG thing. So are there better deals out there? There are. So for those of you who've been members and have stuck with us, we're only here because of you. And as long as I have a foundational membership base, they can't shadow ban us. They can't demonetize us. As long as we have the small number of people who really do believe in the message, we're going to keep bringing it to you. So if you're one of those people that are getting a renewal on your cards this time of year, please believe me when I tell you, not only are we grateful, as we're always grateful, but this time especially, given how hard they're working to make sure that people like us are just put out of business financially. I can't tell you how much it means to me. So thank you. And if you have any problems, just let us know. Okay, I think that'll do it for 183. Pleasure seeing all of you as always. We upload this right now to YouTube. And this time I'm going to try to remember to turn off the live feed, because that could have been bad last time. You never know what you're going to get. Honey, I'm on my way home. And as for the rest of you, I expect I will see you next week on the Stratosphere Lounge.